a lot of things that we do in the sciences is all evolve around reactions. But to the physicists and the chemists, reactions are not isolated. So we have the action, we have the reaction. And so there are various examples that we can give from this from the sciences. And part of this is because it is very difficult for the scientists to say that here is the action and here is the reaction. So it becomes a relative thing. And so my whole conversation is going to be surrounding action and reaction, a case for relativity, Newton versus Einstein. Now, why Newton versus Einstein? Because these two scientists have drastically changed a lot of our views about what is an action and what is a reaction. So, take for example Newton. Newton's third law of motion tells us that for any isolated system, the action and the reaction are equal and opposite in direction. So what does that mean? All that is telling us is that both the action and the reaction are essentially the same thing. And so if we know one reaction, I can know what was the action that caused that reaction. So most of physics in understanding forces is all based on pairs. So there is no isolated force in nature. Okay. Now, one of the most important forces in nature, at least to my mind, is friction. Friction is one of the most important forces in nature. We cannot do without friction, for example, but it is a result of a reaction. So when I walk, again, there is an action. I push down on the earth pushes back on me, and I project myself forward. I am not able to fall because that friction force is holding me. Driving, the tires rotating, again, friction. So friction is very important for all our daily activities, whether you're sitting down, you're standing, it is all about friction. It's all about a reaction. That reaction that we are calling friction, that opposes what we're trying to do. Again, that comes into mind Newton's third law of motion. Now, where does Einstein fit into this? Now, I mention Einstein because Einstein did something revolutionary, where he looked at the law of gravitation. Now, the law of gravitation essentially tries to explain what is the source of gravitation, where does it come from? Now, when you think about it, Newton explained that to us in a very simple way. For a very long time, that was the accepted explanation of gravitation. And Einstein said, wait a minute, that is not exactly how gravitation occurs. Now, what is the reaction of the scientific community to this? Now, because of the way science works, there was a lot of doubt on what Einstein was saying, but at the same time, we follow what we call the scientific method. So what does the scientific method tell us? Again, we observe. Now that point of observation can become our action. And we hypothesize. We said, okay, what is the explanation to this? Tentative explanation to that. Now next, we said, okay, it is not enough for us to say that we've got an explanation, but we need to have an investigation. We experiment. We look at things. We said, okay, based on this, it is really true. This is how gravitation works. And so that was the comparison now between Einstein and Newton. One of them has a very simple formulation, the other one very complicated, but it got tested and it was much better explanation than what Newton proposed. Now, all these examples that I just gave is all from physics, but Physics is not the only place where we can find action and reaction. Let's take chemistry. The whole of study of chemistry is about reactions. Okay? But of course, as some will say, there is always the physics there as well. So let's take a few examples of how action reaction play a role in what we do in chemistry, for instance. Now, for any reaction, there must be a combination of one or more elements, or compounds, or substances that must come together. Now, whether there is going to be something we will observe or not depends on what we are putting together. And so, our reaction to the combination of one or two or more things may lead us to understand the mechanism, to understand the process, to understand more about the materials we are putting together. So we've got a reaction, and out of that reaction, we can tell a lot of properties about the things that we are putting together. That may sound counterintuitive at times, but when you look deep, the physics of it, that is just how it works, because there are at times it is just impossible for us to know what is the action, but we can glaringly see what the reaction was. And so if we understand the reaction, we can go back and say, oh, okay, this is where the action is. And so I'm going to give a couple of demonstrations here that will illustrate the point of action and reaction for us. We are going to see a visible reaction, okay? So there will be an action and there will be a visible reaction. And out of that visible reaction, we're going to decipher from that what exactly are we putting together. So I'm going to get myself protected, and we get the materials going. So we make sure we're well protected on this because of the nature of the materials that we are going to be putting together and the possible reactions that will occur. So I'll tough to get out. So this whole thing has to be stored under some special oils because of the way they react. So I'm going to try and cut through that. This is actually a metal, but it's a very soft metal and looking very shiny inside. So we try the next one. Both of these are very similar. Again, a very soft metal. So set them apart a little bit. Okay, so this is where the fun occurs. Let's get it all out. This time we're going to try and contain the reaction within these flasks, and we will see, again, we're going to observe what will happen. There is an action, there is a reaction, and let's see how these two things will react to their reaction. So let's tidy up our place for a moment. So we try to limit how much of this stuff we use, because the big chunk that I took out initially, that will have caused a lot of explosions. Take this. We're going to essentially repeat the same thing. So that's a very cool set of reactions. See the difference, what happens when we put it out in the open versus what happens when we contain it within the flasks. Chemistry, physics can look at that and be able to explain the reaction. Why was it when it was in open, explosions weren't that much, lighting wasn't that much, but when it is contained, it gives us a totally different set of observations. And from this set of observations, now we have our reactions. We can go back, track back, and say, this is what is happening. This is what was the cause of this. And we can begin to understand the physics, the chemistry of the materials that were put together initially. So from the simple experimentation that we just did, which is what the scientific method is all about, we observe, we hypothesize, we investigate or experiment. In our simple setup experimentation we just did, we've seen an action. On a microscopic level, on a bigger scale level, what you've seen me done was to add water to a metal, to something. And that substance, its reaction to coming in touch with water was to cause that reaction. So we saw a flame, a smoke, an explosion. And then in the second demonstration, you've noticed that we now have this contained in these two flasks. Now, what happens? Again, there is a flame, an explosion, even a much greater explosion. So, what the physicist, the chemist would do is to look at these reactions, to look at what happens when we put these things together. We can now use those to then explain what was the beginning. What did we put together? What are the properties of the things that we put together cause those reactions? So reactions for the scientist, for the chemist, for the physicist is a way for us to be able to understand what was before. We do not necessarily have to be there when these things happen, but what happens after it can tell us a lot about what was there before it. So, in a nutshell, what we are saying here is that reactions are as important to us, even though some of them may not cause the effect we want, but they are as important as the action. Even so, more important. So, to give you a couple of other illustrations to end this, one of the most important reactions that we have used over and over again from physics point of view is projectiles. Nobody really think about it, that projectiles are actually reactions that through another action that we make use of that to send astronauts into space during space explorations. And we can explain all of that through the simple rule that Newton established of motion. Action and reaction are equal and opposite in action. We take jet engines. They pull in the air, they propel forward. Again, action, reaction, pair. As I've pointed out, it is always difficult to know what exactly is the action and what exactly is the reaction. That can get lost at times. Let's go back to our simple experiment. What exactly was the action? Was it really because I put water on that and that is why it exploded, or there is something else? So we must be able to look carefully, and that is what science is all about. And that is what incites the curiosity of the scientist to start off on that journey, make a simple observation, and they said there must be something deeper in that observation, all because of the reaction. It is all in the physics. It is all in the way things react with one another. It is all, in a nutshell, in the reaction. We understand the reaction, we understand the action. We understand the reaction, we understand the physics. We understand the reaction, we understand the chemistry. So, to quickly conclude with this, as we all go out, now let's look at our environment. Anything that we're doing from the point of view of the scientists, let's see if we can recognize what is an action, what is a reaction. Let's see if we can trace back that reaction back to what the action might have been. Could it be you observe a rainbow and you're wondering what may be the cause of this? Can we trace it back to what it might be? A simple observation that we've all seen over and over again. Maybe it's the eclipse of the sun. Again, over and over again, we've observed that periodically. And do we need to know what the cause may be for us to know what a reaction may be? Maybe not. But what we see is the reaction, and we can trace that back and know that this may be the source of what we are observing. The other task that I will give everyone here is this, that let us now be mindful as you walk. What moves you forward? What is the friction? You drive, you hit on that gas pedal. Is that really what is making the car move forward? What is the action? What is the reaction of you hitting that gas pedal that is causing the car to sprint forward even more or to accelerate? So, as we recognize in our environment that action-reaction pair, there is a lot we can learn about the world of the scientists and how, just by simple scientific method, those three elements that I stated earlier on from the beginning, right? So we observe, we hypothesize, we try to explain, or we do an investigation, and we go back and do the same thing over and over again. And that is what makes it possible for us to understand the reaction, and that may just help us to understand what may have that reaction, or in other words, what in science we will call the action. And so, in truth, the action and the reaction are essentially the same thing. And so understanding one, you understand the other.